Welcome. This is the re-recording of today's presentation, the topic on CSS animations. I am Matthew Polson, and let's go ahead and get started. So the goals of this presentation are first to get you to have a desire to use animations. I want you to want to use animations. And then I want you to know how to use those animations and use them correctly. And know what things you should animate. And then after that, I want to empower you and enable you to then create those animations in CSS. So why do we want to use animations? Well, animations help the user cope with state changes, and they help to guide, they can be used to help guide the user's attention to what is important and what they need to pay attention to on your web pages. So a quote by a lady named Aurora Bedford, who works for a UX consultant group called Norman Group. So they are kind of experts in the field of user experience and such things as animations, is quoted to say, moving elements are a powerful tool to attract users' attention. When designing an animation, consider its goal, its frequency of occurrence, and its mechanics. So what are some things that animations can do? As stated before, animations help orient a user after some kind of state has changed. They can help the user understand what the functionality is of something after maybe it has changed. So say some kind of button has a different functionality after it's been used once. It can help highlight some obscure state change. So something that the user might not recognize that the state changed, you'd be able to see, you could help highlight to that user what that state change was. Animations can also be used to help inform the user of what the functionality of something is. So let's go over some examples of these. So orientation. So here's an example that most people that use Macs would recognize. So we've got this state change of this window. And so this helps illustrate and keep in the user's mind that this, or reinforce in the user's mind that this menu that is popping up belongs inside of this button, that's kind of a mental model that users have when they're using interfaces. A very similar one is this menu that pops out of this button here. So this is used as opposed to just cutting to that state. Some people, you could argue that people are used to state just cutting. That's something that they do in things like movies where they just cut from one scene to another. But these animations help make these transitions a little more seamless and a little more easy for the user to understand what's happening, which makes the overall experience for your user better. So another example is functionality change. So here we have a button that when clicked, its purpose changes. We don't necessarily have the context of what this app is, but this could be something like a checkbox or something that you're adding and then are then given the ability to check that to-do was completed. So if you had some kind of to-do app or something like that. Another example is this audio changing. This button that in one mode, one state, it's a mute button, and another, it's an unmute button. And it helps illustrate to the user that functionality of this button has changed. So like just cutting to different states, zoom in is a way to zoom into a particular state. So we have one state where we're focused on a particular part and where we have a list of the different parts. Very similar to that, we have this. And there's this menu that pops up when you're selecting that button. And instead of just cutting to it, we zoom in on that button. Now let's highlight, here's an example of highlighting some kind of state change that's obscure that someone might not recognize. So that item is now added to the shopping cart. One thing I would point out here is that the animation starts, the start of this element that's going to be animated is spawning from the thing that is triggered. So the user's attention would be on this button that they're clicking, and then from there we create an element. That moving item could come from anywhere on the page, where we're not limited to where it would come, but the start of that animation is originating from where the user's focus already is, which again helps the user understand your animation. So animations can also give feedback to what the functionality of a different element is. So here it helps illustrate that these are buttons, that they have some kind of action or some kind of functionality. This is one that I really like, this type of effect. If you've ever been on using a website on a smartphone, and you select on something, and you're not sure if you actually did select on it. Maybe you didn't hit it. That's something that happens. You click, and you didn't actually click on the element. Well, with something like this kind of feedback, it helps illustrate to the user that you did indeed click on the element. It gives that feedback of this is what you clicked on. This is what I believe you clicked on with these ripple effects. And this effect would occur from where would propagate from where the user clicked. All right, so now I want to go a little more deeper into what are principles that you should follow. A good place where you can get information on this, and where I think is a really good source for these types of principles, is Google Material Designs, which I have a link here. And they go over several different principles of just design, but they have an entire section on animations. Another thing that Google has is their Rail performance model, and one of the parts of their performance model is about animations. Animations, they say, should occur within 60 frames per second. 60 frames per second is the speed at which humans visually see animations, and anything past that is not necessarily needed, but anything slower than that, and your user will start to recognize, and will be able to start notice this jank in your animations. And the way to achieve 60 frames per second is to make sure that every one of your frames renders within 16 milliseconds. And there's tools that Chrome has, and other, I believe Firefox as well has, to help you see those animations and see if your animations have parts that aren't rendering in 16 milliseconds. So some of the first principles that Google Material Designs talks about, the first one that I wanted to talk about is speed, or how fast your animation is. So animations should be fast enough that we don't make the user wait, and slow enough that they understand what has happened. So here we have two examples. We have a good example, is an appropriate speed, and a bad example. This is taking way too long. And yes, it might help the user understand the animation a little better the first time they see it, but every time after that, it would be very tedious and would feel like just get on with it. At least that's the feeling I would have, or I do have when I encounter really slow animations that interfere with my ability to interact with the rest of the system. So animations that are larger might need to take a little bit longer. So say they cover more real estate of the screen, or maybe you need them to potentially coverup's not quite the right word, but help you cover some asynchronous functionality that's occurring and help almost distract from that. Maybe you could go a bit longer, but I would tend to say you should avoid doing that if you can. That you should not have your animations be any longer than this, otherwise you will start getting into this bad area. But animations shouldn't be too short. So shorter animations, things that are much smaller, there's not a whole lot happening with them. You just need to illustrate something small. Those should occur within 150 to 200 milliseconds is what the material design's suggestions are. The next thing I want to talk about is natural easing curves. So objects in the real world, when they move, they don't move in a linear fashion. They accelerate. They go from a stopped point, accelerate to a speed, and then once they approach their destination, they slow down. So in this illustration, we see an object that's moving linearly and one that has some easing to it. Animation should create a clear and smooth focal point. So here it is clear that the focal point is this circle, and this is the state. It's like maybe a little button or thumbnail of an article or something. The animation is clear that this is the thing that you should focus on. Another thing that I would note is at the end state, this is where you want the user to start their experience with this new state. So we're guiding them to that point. You want them to start at the beginning of the article. Well, let's go ahead and do that. So it's easier for them to consume that content. It just makes the experience for the user easier. When an animation has multiple elements that could be visible in an animation, so we notice, some actually don't notice that in this first example that these elements are shared. We have 3 dots and this maybe title bar of some kind. Those disappear in this animation and then just simply reappear because we want the user to focus on this one element because that is the starting point of the article at the end point. Here in the bad example, there's way too much happening. It's hard for the user to focus. They don't know what they should be focusing on. And so there's a likelihood that at the end of the animation, they wouldn't be focusing on the right thing and would have to reorient themselves once it is finished, which is just delays and makes things a little bit harder for your user when using your interface. When creating a new surface, that element or whatever it is that you're creating should propagate from the point of origin. Again, this is kind of reiterating principles we've already talked about, but illustrating them a little more clearly. So the user's attention would be on this button. They click on it, this new state appears from that button. Here, it appears from a seemingly random location. And it's slightly confusing to the user, could disorient them. Even if it's just a slight confusion, something that's very slow, very minimal, things like that can start to add up and make your interface unpleasant for the user. And it might even be hard for them to express why it's frustrating for them. So again, the ripple effect, we've already kind of talked about that, but things should propagate from that ripple effect. There's another example here that I really like, this image gallery, where they select an element. Notice that the elements, the other thumbnails, disappear, but in a way that propagates from the selected element. All right, so now we've talked about some principles. Let's start to get to talking about how you actually animate things. So CSS properties, what CSS properties can you animate? And I've broken up this following section into 3 parts. And 3 parts are properties that are very inexpensive to animate, ones that are a little more expensive, and ones that are even more expensive to animate. And this is expensive in regards to performance of those animations. And it's not to say that the expensive ones are ones that you shouldn't do. It's more of just to make you aware that you could potentially have more issues with them, that you should strive to use ones that are less expensive. Also, the properties that you animate in CSS are all properties that have some form of units involved with them. So here are some of the less expensive animations. The reason why they're less expensive is because they are composite, or what is called composite. And so in the layer rendering lifecycle of the browser, it happens at this much easier lower level of what's called composite. And it means that the actual GPU of the device can actually render this. These properties are translate, scale, and rotate, and then opacity. So properties that are a little more expensive, and the reason why they are is because they trigger a paint, meaning that the browser has to repaint what's on the screen. So things like color, border radius, background. Next, we have properties that are even more expensive, and the reason why they are more expensive, strictly more expensive than these ones, are because they trigger a layout, which then in turn triggers a paint. So they are strictly more expensive because they have to trigger an entire paint. Not to say that these properties are ones that you can't animate. You are very able and capable of animating them and making them hit that 16 millisecond benchmark that we want to aim for. So we have width, height, padding. Notice that in changing these properties on elements, it could change the dimensions, which means the browser has to calculate the size of that element with every single frame, and potentially even recalculate the positioning of not just the element itself, but other elements that it is siblings to, because it could change how certain elements wrap with each other, or et cetera, et cetera. So now properties that you would think you can animate, but you actually can't. You can't animate these things. And you would think you can, but you just can't. Width and height auto, you would think that that's an actual unit, but it's not. You can't go from 0 width to auto width and have it actually animate. The browser isn't capable of that. Being able to animate from to and from display none just doesn't work. It doesn't do an animation. You'd still have this transition, but it would be a sharp transition. There would be no animation to it. You can't animate from any of the to or from any of the floats. And then you cannot animate to and from static and absolute. So you can't go from static to absolute or absolute to static and have it be animated. All right, so next, how do we actually animate these CSS properties? Well, there's two things. There is what's known as transitions, and then another known as keyframes/animations. So let's go ahead and dive into those. But first, a few examples. So in this first one, recognize that there is no animation. This is just a simple operation, just a simple state change, very, very sharp, very cut to and from, right? These animations are strictly additive to this core functionality. We're simply adding a transition. So here we have two states, one where it is open to a given height, so this element now has a given height, to 0 height. So from 0 to, I think it's like 10 ems I'm using here. So we go from 0 to 10, and we have a transition that says let's move to and from that location. And then keyframes, a note that there's a little more happening than just moving to and from the endpoints. There's an additional little bump in between. That's to illustrate that keyframes enable you to do slightly more powerful things, potentially very more powerful, much greater powerful things. All right, so let's go ahead and take a look at can I use before we actually dive into them. The can I use for these are exactly the same, as you'll notice. They're very much the same. And it is very green on both of them. You can use all these features in all use cases. And even places where you can't, say IE8, if you actually do need to support IE8, recognize that you should be doing these animations in a way that is additive. So that this would be the core functionality. And so if, say, the user's on IE8, this is what they would experience. But if they're not, then they would have this much greater animated experience. All right. So let's go ahead and dive into transitions. So transitions, as I mentioned briefly before, is just simply animating from one property to that property being changed. So some property of an element is changed. In the previous example, it was height. So we changed the height of an element. And transition simply says, let's animate that change instead of just snap right to it. So how does that work? Well, here, in a very verbose form, we select the property that we want to animate by using transition property, and then we set the duration of that property. Here we set it to 0.3 seconds, and the property being max height. Note that there is a shorthand for this, which is what I almost always use, where you just state transition, and then you state the property and the time. There's additional properties that you can add on to these, which I will get into shortly. Here's another example where I'm using this shorthand, and note that I am able to do more than one property by simply putting a comma in between them. So I have a max height 0.3 seconds, comma, opacity 0.3 seconds. So now these elements fade in and out in that transition. And note that the way that this happens, this element constantly has this class, which means that this element that I'm animating, this little hidden element, has this transition constantly applied to it. So when that property gets changed because we've added a class showAnimated, the max height is no longer 0, it is now 90 pixels. And the opacity is no longer 0, but 1. So then this transition kicks in and says, we need to animate these properties in this duration of 0.3 seconds and 0.3 seconds. Now, if you remember before, one of the principles that we talked about is that elements don't just move to and from their things in a linear fashion. They have some kind of easing to them. Well, we have what is known as transition timing functions. These are different ways that we can ease our animations. I have an example here. Note all of the different ways. Also know that all the elements arrive to their destination at the same time because they all have a set duration. They just have a different easing function. So ease, it starts out slow, speeds up, and then slows down before it reaches its destination. Ease in starts slow and then accelerates to its destination. Ease out is fast and slows to its destination, so on and so forth. Cubic Bezier is a custom. If I can click on this. There we go. One thing I want to point out that Chrome DevTools has to help you with these timing functions is if you look at this little purple box here on this timing function, you can select it and it will bring up this menu, which you then are able to customize this curve. And here you get a little preview of what that will look like. You can do many crazy things here. Even cause the animation to go in reverse at some point in the animation. All right. Now, also in Google Material Designs, they actually have a suggested standard curve that you should use. And here, this cubic Bezier is that suggested standard curve that they have given us. And it is the one that I had originally with this cubic Bezier. Let's continue. So now here I have this same drop down with the max height, and I've just simply added that cubic Bezier curve that Google gave us to the speed of the max height. I didn't necessarily feel like it was necessary for the opacity because there's not necessarily anything moving. It's just how it's going to kind of fade in. But you could add a cubic Bezier curve on that as well if that is what you needed. Now let's talk about animations and keyframes. Remember, these are slightly more powerful and a little trickier than just doing transitions. So with animation keyframes, you first define your keyframes. You can think of this as kind of a variable that you set. You define the different properties, the different property values that you want to have applied to your animation at what point in that animation. You then take that keyframe and you apply it to an element and define how that animation should then behave on that element. So let's go ahead and look at an example. That was kind of a hard definition to understand. I personally learn better with examples anyways. So here we have keyframes. So this show drawer keyframe, we at 0% of the animation, we want it to be at height. This is like saying at the start of the animation, it's going to be at 0. You can also here say 2 instead of 0, and instead of 100, you could say from. That is an allowed syntax. You then can, at any point in between 0 to 100, add additional points. Here I just added 1, so at 30%, I want the height to be 100 pixels. And then at the end, I want it to be 90. So we're going to animate from 0 to 100 pixels, and then from 100 pixels to 90 pixels throughout the life cycle of this animation. That gives us that little bounce. Then to hide the drawer is very similar to show, except we are doing it in reverse. We go from 90 pixels to 100, and then from 100 to 50, and then to 0. And then I also changed at what point in the animation that this should occur. So instead of happening at 30%, it's happening at 50. We then take these keyframes, and to get them to apply to this, I have some JavaScript that's applying classes behind the scenes. We will cover triggering these animations later. But we have this show class that gets applied when we want to show, and then a hide class that gets applied when we want to hide. At the same time, we remove the show, and vice versa. We then say on these classes, we do an animation property. We define the keyframe animation. This is what was defined here. So this is the same show drawer and show drawer. Then we then say the duration of the animation, and then we can pass it an easen function. There's additional properties that I will cover now. These additional properties, we have animation delay. It's pretty self-explanatory. You can simply define how much of a delay should occur before the animation actually happens. You can also there's animation direction. So if you wanted to have the animation play but in reverse, you are able to do that with this. And then if you have more than one iteration, you have this alternate and alternate reverse. Alternate would simply go from 0 to 100 and then 100 to 0 and back, vice versa. And alternate reverse would start at 100, go to 0, and then from 0 to 100, and vice versa for each iteration. So the iteration, we can define infinite or some number of iterations that we want that animation to occur. We also then have an animation play state that we can interact with. So this allows us to programmatically add this property using JavaScript. We could pause the animation. So if the animation is halfway through, we can add this property. It would stop the animation right where, and the element would remain at where it's at whatever point in that animation. And then we could add the running, and that animation would continue from where it left off. Here I have an example of transition and animations together. So I'm using transitions to animate the ball moving across the screen. I'm doing this at a linear rate. And then I'm using keyframes to create the bouncing. Code pins are here if you feel like you want to come back and dissect how I accomplish this. So now, what are the different ways that we can integrate these animations, or how do we trigger them? One of the main ways is to use pseudo-classes. The pseudo-class selectors include things such as hover or focus, or also things like the validity of a form. So here we have a simple hover state. Simply hover over the element and it will animate. Here I have a form invalid. So if I just do that is not a valid email. And so this animation plays when it gets validated. But then if I make it a valid email address, that animation does not occur. Now, as I've used in previous examples, you can programmatically add or remove classes to your different elements using these methods. So here you would do some kind of query selector to get a node, and then all nodes have the method class list, which has the methods add, remove, and toggle that you then give a string, and that string would be the actual class name that you want to add, remove, or toggle from the element. So here in my JavaScript example, I have added an event listener, click, that will then get this node. Well, it has a reference to this node, which I then call classlist toggle example active, being the class that I toggle. So on each click, it either removes or adds, depending upon what class, if that class is already present on the element. I would suggest you try using CSS pseudo class selectors before you use JavaScript, but I think it is also very important to know and understand the ways to manipulate these using these JavaScript methods. They are very not uncommon to use the JavaScript methods. I just suggest seeing if the CSS ones will work for you first. Now lastly, I want to share with you the Firefox animation panel. There's just a few, I just want to briefly kind of show it to you. I don't have an example ready yet, so I'll just grab this. So once this animation begins, this animation panel shows. I can go here and this allows you to go at any point in the animation, change the speed of the animation. So you can reset and slowly play it. So you can walk through the animation at all the different points and see it a little more precise. So that if you have problems with an animation, this would allow you to debug some of those problems. So that is my presentation on CSS animations.